Alright, now that we've seen the basics, I can move on to showing you the main building blocks of most games. If we add a part in the game, and inside of there we add a script, basically how Roblox works is that when you get something such as script.parent, which in this case is the part, you can press dot, and then there are a bunch of stuff in here. These are all properties. If you look down, you can find these lightning bolts. These are called events, and what happens is that whenever what it says on the wiki, what it triggers, happens, it will start something linked to it. So, for instance, touched. This will basically trigger. Now you have to, it's the event where you have to connect it to something. So if we have connect, this will run whatever is in here, but it has to be a function in this case. So there are two options. Either we do a function outside of this, function like touch part. Getting into functions, you just start with function, have a name for whatever you want it to be, and then it does not matter what you call it in here, it's just the order that matters. So here I have part, and basically what it does is if I give this function right here a parameter, so if I do touch like this, it will run this function, so it will like go here and do everything in here. If I give it something in here, such as script.parent, which is the part, if I give him this, then it will do this, and part will equal script.parent. So if I were to print part in here, I would print this object right here. And if I want to add something else, so like say, I don't know, size. So I want to get the size property of this part. I can go script.parent.size, and then this is now the size. Again, it doesn't matter what you call it. You can call it I don't know, and it'll still work. So you would just call it I don't know, and it would give you the size of the part in this case. Anyways, going back to events, over here you connect it to a function. So if you connect it to touch, this will happen instantly. Now, if you go over here, script.parent.touched, you can look up the event touched online, and you can find what it gives you and what triggers it. So, for instance, for touched, whenever the object gets touched by another object, not just players, just like another part, it will connect it to this function right here. And what it'll give in here, because even though you don't put anything in parameters, it's still gonna just autocomplete it with what connects, what the event gives back anyway. A part, in this case, with touched, it means the object that touched the part. So if we have print part, actually we're going to print part.name, it's the same thing. It's going to print the same thing. It's just that well, instead of printing the actual instance, you're printing the name of the object. It's going to print the same thing in the end, but it's just personal preference. It's less confusing that way. Well, it may be for you, but once you get far enough, it'll make more sense. Anyway, so we have this part. We told it to connect touched, so that when you walk or anything touches it, it prints what touched it. So if my computer speeds up, I will be able to show you that. Oh boy. Yeah, I need to get a new computer. Pretty bad. While this is going on, feel free to skip. I cannot edit my videos. Alright, so as you can see, base plate right here, it just went on the base plate. So since it has gravity, it considered like it initially touching the base plate as gravity. And over here in part, as you can see, there's touch interest. This is automatically added to something that has that event on it. This is like really old and you don't have to do it again. Anyway, so over here it just said base plate again. That's because the gravity, since it's not perfect, just did it again, which is kind of strange, but that's how it works. So if you see right here, it prints, if Roblox didn't know how to save every single second, as you can see right here, every single time one of my body parts touches it, it prints the thing. This is one event. Now the other way you can have an event work is that instead of having the function called, saying the function and then binding it to this, instead of that, you can just write it here instead. So, function, then you end it like this. Now this is basically its own function, however, you do need to put in what it is in here. I do know why. It's because if you never say what it's called, you're never going to be able to use it. It's going to instantly say what is in the first place, but if you can never use the thing in the first place because you never give it a name, you can't use it. So if you do print part.name in this case, if my computer works, thank you. Yep, as you can see, it just printed base plate like this. So now you may be thinking, how is this helpful for me? Well, you may not be thinking it, but let me give you an example. Part.parent. Now, if we say left foot, okay? So if we put in a rig right here, dummy. Okay, so left foot somewhere around here. Left foot right here. So let's say this touches it, okay? So we can go part.parent, which is a character, and then you can go find first child humanoid. Again, if the part touches the base plate, it is still going to assume that it has a humanoid, and the base plate does not, so else the script will crash. And then we can say, okay, so this is variables. What a variable is, it's just something you call an object. So if I say humanoid equals this, humanoid will just refer to this. If it finds something, humanoid will equal this right here, but like already found, it'll just immediately equal the humanoid in here. And if it doesn't find it, it'll equal nil. Also, you put in local. You want to use it for pretty much everything, even out here. What local is that it makes it so that when you define something, it is only part of this here. So if I say local here and I call it humanoid in here, then this humanoid in here would be called this. If I were to say print humanoid in here, it doesn't know what humanoid is because it is local to this function right here. And this works with other stuff, such as if functions. If is a list of parameters you can do whether or not you want to have something happen depending on something or not. So if humanoid equals, well, not even equals, like does not equal nil, then so if humanoid does not equal what it gives back if there isn't anything in here, which is nil, as we've seen in the last episode, then we can do something over here. So let's say local variable equals 1, and you can get rid of this. If you did print variable, it would equal 1. It would give you 1 in here. However, if you do it outside of it, print variable, it doesn't know what it is because you called it a variable equals 1 inside of here instead. This also means, and this is a bit more advanced, that if you do local variable equals 0 in here, this will print 1 and this will print 0 because it only gets called 1 in here. If you do want it to change for outside of this, you can just remove the local, and it is like the only time you don't want to use local. Now you might be wondering why you need to put local in here. Well, it's simple. You use local in there because it's just easier for a computer to look through stuff that is defined as local. It's like a slight performance increase. Anyway, now for if functions, you can do equals equals, and basically how if works is if true then, and this is an operation. If humanoid equals nil, if it was nil, this right here would equal true. If this wasn't the case, humanoid does not equal nil. If it did not equal nil, then this would equal true. So it's the vice versa. If humanoid is bigger than 1, then if humanoid was a number and also was bigger than 1, then it would be true. Bigger equal, or smaller equal. That's really all the big ones you gotta remember. So if humanoid, then, and this is a little bit more advanced, you can get rid of this if you just want to check if something exists or not. If you put at the beginning if humanoid, if not humanoid, so if this is not real, then it will give you false. Well, not, then it will give you true if there wasn't a humanoid. But if there is, you can just put if humanoid, then it'll see that there is a value and assume it's true. If you put not, if there isn't a value, it'll give you true, pretty much. So instead of doing if humanoid does not equal nil, you can just do humanoid. If you want to check if humanoid did equal nil, you can just do if humanoid, if not humanoid, then. That's literally all there is to if, unless I'm missing something. It's just that. You can use more complex stuff in here, like say I wanted to see, like the player's name was a bunch of numbers and letters. Well, just numbers. And I wanted to compare that with a number, but this is a number, and humanoid is an instance, like an actual object. So what I could do would be like toNumber and humanoid dot parent dot name. So we'll go to humanoid dot parent his name, and it would turn this string of letters and possibly numbers into what the computer reads as numbers, because to a computer this and this is different. This is a number and this is a character for it, and names are considered characters. Going back on track, if humanoid, then so if it finds a humanoid, you can do humanoid take damage 50, or more like 5, and this will make it so that whenever you touch the part, if you are a player, you will take 5 points of damage. You can just check with this, I imagine. Like here, move him over. Unless he doesn't have any health, I imagine. Nope, he does. As you can see, he takes damage whenever he touches it. Just like that. There is a problem you may have noticed in that case, where like every single time he touches it, which is a lot per second, he just keeps taking damage. This can be fixed with something called a debounce. You don't have to call it a debounce, it's just like what people call it. Local debounce equals false. We put it outside of here because if we say what the debounce is by default in here, it will only read it inside of here. So the next time somebody touches the part, it will rerun this and re-say what debounce is, which is false. So instead we call it here, and we use a thing where we don't use local, so that it carries over the next time it's used. So here we can have if not debounce, which is not because it is false, then, and then you can do if humanoid, so only if a player touches it, debounce equals true. And you don't have local, so now this debounce right here is set to true across across all of this, across whenever somebody touches it. And then you can have wait 0.5 seconds, debounce equals false. So debounce equals true, the player can no longer take damage from this, take 5 damage, wait half a second, and then set it back to false. And since debounce is set to true in here, it is not debounce, so it cannot be it cannot run this until that's done. So if we test it, you can see I take 5 points of damage, but only like every half second. There is a big cooldown. Just like that, we have you can just change this number right here and have your damage skip, like your lava block or whatever. So basically the entire backbone of Roblox Lua is really events. There are events for if, say, the player touches a key on his keyboard, and that's how the game registers whether you press something or not. There is an event, an event for if, like for instance, the player tabs out of the game. There is an event for if the player clicks on a text box, so you can't like have him do attacks while he's in the middle of typing something. There's an attack for everything. Well, there's an event for everything. Well, almost everything. And if you want to find an event to do the thing you want to, you can always just look it up online. So we've seen all of this. Now there is only one thing left to do. Clarify a little bit of advanced if stuff. So you can have if, hold on, like variable equals true. I'm going to put it to local first. If variable, then you can have this. And we can have local variable 2 equals false. Then you can have if not variable 2, then like this. This can be turned into a single if. So if you go back here, if variable and not variable 2. Just like that. If you want to have something happen if this entire thing is not real, so it's like if this then do this, else do other thing, you just put else. This will only run if this is not true, and this will only run if this is true. If you want to have another if, but don't want to have and then if, you can just do else if, and then becomes like right here again. You can do like this backwards, for instance, and not like that. So it would this would run just fine, but if I put this to true, then none of them would run. If I put this to false true, like I flip them, like over here how they're flipped, then this will run instead. And I think that's about it for if. That's pretty much all there is to if, unless I forgot something again. Anyways, next time we're going to be looking at something a little bit more advanced, loops, yeah, pretty much. And loops are a little bit complicated. So yeah, see you later.